Oh, I'm talking about money, honey. Hey guys, what's up? Mr. Miller here. I thought I'd try to make another video for you. Hopefully the audio quality is a little bit better this time. I want to say I'm sorry that this problem tripped us up so much in class today. That wasn't my intention. I was most unexpected. And I figure what I would do is I would walk you through the problem in a quick YouTube video. So we have this person, Alexandra, and she's going to invest $11,000, loosely speaking, $11,724 in two separate accounts. So we have two baskets. All right. So the first basket is a bank account that gives 6% interest on whatever amount of money she puts in there. What this means is if she were to deposit $100 in that basket, after a year she would make $6. But she has more than $100 to invest. She has $11,724. She's going to put part of that money in the 6% basket, and then she's going to put the remainder in a different basket, a different account that's going to be a 2% interest rate. The question we're asked here is, how much did she invest in each basket? How much money did she put in the 6% basket? How much did she put in the 2% basket? Grammar police, watch out. Reader, reader. All right, there we go. That should be a question mark, right? Okay, so one way to attack this is through using a table. All right, and since we're talking about simple interest, it would be good to look at that formula again. So our interest is calculated by taking the principal, that's what P is, the amount that you put into the account, the interest rate, and the amount of time. T is in years, so R is going to be the annual interest rate. What percent is the first account? 6%. What percent is the second account? It's 2%. Right? That's what these are, the R's. R is 6%. This R is 2%. So maybe set up a table. We'll call this account 1. We'll call this account 2. Okay, and this is going to have a little bit more columns to it because our interest has 3 other letters in it, our formula, right? Interest is principal times rate times time. So I have some principal. Interest rate is by interest column. Account 1. How much money in account 1? I don't know. That's what we're trying to find. I have no idea how much she's going to put in the first account. So I would say, all right, no big deal. Let X equal money. Account 1. All right, so it's easy. In that box, I'm going to write an X. To get how much money she has left over, we take how much money she started with. She starts off with this amount, and she's going to put X dollars in account 1. So that means in account 2, I wish I would have made this box just a little bit bigger, but it is what it is. I'm going to try and squeeze it in. Okay, that's supposed to be a 2. We would have to take how much money she starts with, and we would need to then subtract off how much money she put in the first account. That would give us how much she has left over to invest in the second account. What's the interest rate of account 1? Well, account 1 has a 6% interest rate, right? So as a decimal, That's going to be 0.06. Time goes by. Boom, 1 year. And that's going to really simplify things because whenever you multiply something by 1, you get that same thing back. It's going to make the problem a bit easier. Now let's look at account 2. Account 2's interest rate is 2%, right? Account 2, 2%. As a decimal, that's 0.02. How much time goes by? Oh, a year. Now, we need to get our I column. How do we get our I column? Our simple interest formula says to take P, take R, take T, and multiply them all together. So, boom, 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 left to right, x times this times 1, 0.06x. In the second row, multiply this stuff together. We will distribute multiply. Okay, now then, for the grand finale, last piece of information we need is this right here. Each account, it's going to earn the same amount of interest. So that means at the end of 1 year, whatever interest I earned in account 1, I'm going to have that same amount of interest earned in account 2. What does that mean we can do with these two things? Did you say set them equal to each other? I think I heard you say that, and you would be correct. That's exactly what we need to do. 0.06 equals. Yeah, I kind of wonder, what does she do for a living to have that kind of money to invest? I'm really, really jealous. I'm always looking for tidbits. Okay. So we're going to now solve this. And I need a calculator. Do this right quick. 11724 times, and of course I picked a calculator that doesn't like to show all the digits, so let me get a different one. 11724 times 0.02, 234.48. Okay, I'll believe anything once. Okay, I'm running out of space, so I'm going to have to write underneath minus, if I distribute to the x, 0.02x. We're going to add that 0.02x to both sides of the equal sign. Go bye-bye. Ah. Oh. I'm going to get you. Okay, there we go. All right, divide both sides by 0.08. And here we go. We are almost there, folks. Whew, what a journey. And for my x, I get 2,931 bucks. What does that number tell us? It tells us that the amount of money she invests in our first account is 2,931. And if we know how much she invested in account 1, we can figure out how much she invested in account 2 by 2,700. 2,900 and I get 8. 8, 8, 8, 8. Just kidding. 8793. Okay, there you have it. The amount in account 1, 2,931. The amount she invested in account due, 8,793. And I'll tell you this right now, if I ever meet this girl, Alexandra, I'm going to sweep her off her feet and woo her and buy her flowers and candy because she, honey, honey. All right, guys, have a good day. Again, I feel bad that this problem didn't go over so well in class today, but we're going to have days like that. That's okay. We just deal with it and move on. Catch you guys later. Have a good day. Bye-bye.